Alright, so on Monday in 6.1 we learned about the law of sines. Now we're going to deal with the law of cosines. So 6.2 is the law of cosines. So these are two formulas. We have the standard form and the alternative form. If we are given three sides of a triangle, we use the alternative form. If we're given two sides and an angle, so two sides, one angle, we use the standard form. So example 1, bless you. Find the three angles of the triangle shown in the figure. So we're given three sides of the triangle. Why can we not use law of sines like we did before? Because there's no angles. We don't have a pair of corresponding angles. We only have three sides that were given. So that's why we have to use the law of cosines. So we always want to start with the largest side, so the longest side. So we start by finding the angle across the longest side. Which is what that whole paragraph below says. So which angle are we going to find first? What's our longest side? B. So we want to find angle B. So we use our formula cosine of B is equal to a squared plus c squared minus b squared over 2ac. So we just plug everything into our formula here. So cosine of B is equal to a squared, which is 8 squared, plus c squared minus b squared over 2ac. So 2 times 8 times 14. Now we just put all of this into our calculator. So on top we got negative 101, and on the bottom 2 times 8 times 14, 224. So we need to find the cosine B is negative 101 over 224. How do we find B? So here we're looking for our angle B. So if we divide this, we would get cosine of B is equal to negative 0.4508. Is that the angle that we're looking for?
You do the inverse.
We do the inverse. So we have to do cosine negative 1 of negative 0.4508. That's going to give us our angle. So what'd you guys get? Well, I got 116.79. Anybody else agree? All right, awesome. So angle B is 116.79. Now what can we do to find one of our other angles? Can we use law of sines now?
Yes.
Yeah, because we have a corresponding side and angle. So we have angle B and side B, so we can use that to find one of our other angles. So we can say sine of 116.79 over 19 is equal to what?
Sine A over 8.
So sine A over A, which A is 8, so sine A over 8. How do we solve for angle A? What do we need to do? Cross multiply. So we have 8 times sine of 116.79 is equal to 19 times sine of A. Divide both sides by 19. Now we put this into our calculator. So I got sine of A is equal to 0.3758. Is that my answer? How do I find angle A? Take the inverse.
Again.
So we have sine negative 1 of 0.3758. What'd you guys get? Well, I got 22.07 degrees. So this was angle A that we found, 22.07. So we said to find angle C, we add our two angles that we have and subtract from 180, and we got 41.14. Awesome. So just like when we did for law of sines, since we were given 3 sides, we still have to check to see if we have 2 triangles. So we have triangle 1, triangle 2. The first angle we found was 116.79, so that's going to be the same in both of these, 116.79. The second angle we found was 22.07. The second angle in triangle 2 is going to be the supplement of that. So how do we find the second angle in triangle 2? How do we find the supplement?
You subtract from 180.
Subtract from 180. So 180 minus 22.07. What do we get? $157.93.
0.93.
Next, we need to add these two together and then subtract from 180 to find what our third angle is. So what's 116.79 plus 157.93?
It's over 180.
Over 180. It's like 223-ish. 224. Over 180. So do we have a second triangle here? Nope.
No.
So no second triangle. So these are our 3 angles that we had to find.
Do you always have to try to see if you
Yes. In law of cosines, you always have to see. So if it gives you 3 sides, so 3 sides or 2 sides, 1 angle, we need to check. So the only time you don't have to check is if it gives you 2 angles and 1 side.
Can you add for the second side, you just add those and they equal 180?
You add them if they're over 180. So since this is over 180, then we don't have a second triangle. If it was less than 180, let's say it was like 100. We added them, we got 100. That would mean our third angle was 80. so then we would have two triangles.
And why do you start with 116?
We start with the first angle that we found. And that's why we have to find the largest angle first, so the angle across the longest side. So that's why we have to start here. Here we have two sides and an angle. So which formula are we going to use, standard form or alternative form?
Standard.
Standard form. So we're going to use our first formula up here. So we just need to plug everything into our formula. So we have a squared is equal to b squared, so 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of a. Now we put this all into our calculator. So we get 81 plus 144 minus 2 times 9 times 12 times cosine of 25. So what do you guys get for a squared? $29.24. So then how do we find a? Take the square root.
$5.41.
Awesome. We're just going to round it to 5.4. So a is equal to 5.4. Now that we have a pair of corresponding angle and side, can we use law of sines? Yeah. So I like to change back to law of sines. We could still use law of cosines to find our other angle, but I think law of sines is just a little bit easier. So we have sine of 25 over 5.4 is equal to what? Jasmine, what did you say this is equal to? Awesome. Sine b over 9. How do we solve for b? Cross multiply. And then divide by 5.4. So we just need to put this into our calculator. So I got sine of b is equal to 0.7043. We could say 4, because it rounds up. Is this our angle? How do we find the angle?
Inverse.
The inverse. So sine -1 of 0.7044.
$44.8.
44.8. Perfect. So that was angle B, 44.8 degrees. And then how can we find angle C?
Add the two angles and then subtract from 180.
Perfect. Add the two angles, subtract from 180. So what do you guys get for angle C? $110.2. 110.2. And since we were given two sides and one angle, we have to check and see if we have two triangles here. So we start with the angle that we were given, which was 25. So that's our first angle in both the triangles. The second one we found was 44.8. We need to find the supplement of 44.8, so we're going to do 180 minus 44.8, and what do we get? $135.2. We add these two together. We get 160.2. Do we have the possibility of a second triangle here? Yep.
Yes.
So we do 180 minus 160.2. We get 19.8. So this would be our second triangle. So the pitcher's mound on a softball field is 43 feet from home plate. The distance between the base is 60 feet as shown in figure 6.9. The pitcher's mound is not halfway between the home plate and second base. How far is the pitcher's mound from first base? So we're looking for H here. So we are given an angle and two sides. How can we find that third side, H? What do we have to do? Can we use law of sines here?
No.
No, because we weren't given an angle and its corresponding side. So we can't use law of sines, we have to use law of cosines. So go back to your law of cosines formula. Alright, so we're using standard form. So we have a squared is equal to b squared plus c squared minus 2bc cosine a. So h is going to be our a squared. This is what we're trying to, or our a, that's what we're trying to find. And then we can plug in, we can say this is b and this is c. So let's plug them in. So 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45. So this is equal to a squared. So now we put all of this into our calculator. It's important that you guys actually try putting them into your calculator so you kind of understand how to do it in your calculator and know what steps you need to follow, because some calculators are a little bit smarter than others. So you guys need to practice putting these into your calculator. Alright, so what do you guys get for a squared? I got 1,800.33. How do I find what a is? How do I get rid of that squared?
Square root.
Square root. So I need to take the square root of this. $42.43. Perfect. And that's our answer. This question just asks for how far the pitcher's mound is from first base. So all we needed to do was find A. Okay, so lastly we have Herons area formula. So we use this when we have all three sides and it asks for area. So first thing we need to do is find what our S is, and then we use that S and plug it into our area formula, which is this one here. So we have two formulas here that help us find the area. So find the area of the triangle shown below. We have all three sides given, so we have to use Herons' formula. So first we have to find S. So S is equal to all three sides divided by 2. So S is equal to 53 plus 43 plus 72 over 2. What do you guys get for S? 84. Perfect. So now we use that and plug it into our area formula. So we have the square root of S, so 84 times 84 minus each side multiplied to each other. So 84 minus 53 times 84 minus 43 times 84 minus 72. I'm going to subtract each one first. So we have 84 minus 53. So this is 31. 84 minus 43. 41. And 84 minus 72. It's 12 times 84. Now I can do all of this together. So 84 times 31 times 41 times 12. And I get 1,281,168, and then I take the square root of it. So what do you guys get for the area?
$31.9.
1,131.9. Awesome. And what would our units be?
Meters squared.
Awesome. Meters squared. The last slide is just our three area formulas that we know. So if the height was given to us, going back to the last example, our triangle looked like this. If we had a height going through that was perpendicular to the base, if we knew what this was, we could just do 1/2 base times height. We have that formula. But since that height was not given to us, and all three sides were given to us, we had to use Herons' formula. So we use this one when we have three sides. And then we use the oblique triangle area formula when we have two sides and the included angle. And then you can use the standard area formula of a triangle when you have the height.